This session is related to business statistics, where we will be discussing the topic regression analysis. There are a lot of tools which are used in statistics which help us to identify the real meaning of numbers which are there. And this particular analysis, regression, is closely related to another analysis called correlation, wherein how variables are related to one another and what happens when one variable increases, how does it impact the other variable. As the very word regression, we understand that as opposite of the word progression. Progress is to go forward, whereas regression is to go backward. So here regression is the act of returning or going back. That is how we understand the meaning of the word regression. So when we go back, we are trying to establish some kind of a relationship or some kind of values we are trying to estimate and predict between the variables. Basically, this word regression was used for the first time in the year 1877 by an English scientist by name Galton, Sir Francis Galton, who actually was doing a research on heredity, and he was trying to identify if there is any kind of a relationship which is there between the height of fathers and the height of sons. He was the person who used the term regression for the first time. And the line that he was using to describe this kind of a relationship or a tendency to go back or the tendency to attach itself, he used the word regression line. His publication was in the form of a research paper which was titled as Regression Towards Mediocrity in Hereditary Stature, where he used the term regression for the first time. In modern days, the authors are using the word estimation line instead of the word regression line, because the word estimation conveys a better meaning and a more clarity in terms of predicting the values rather than the word regression. So today, instead of using regression line, we also use the term estimation line or prediction line, which means the same, where we are trying to find out what kind of a relationship is there between two different variables or multiple variables which are being used. The variables which are being used are also meaning different things in this entire analysis which is there. Now, when we are doing an analysis of any item or any phenomena, we are basically trying to identify and describe that particular phenomena and trying to also identify what all are the variables associated with that particular phenomena. Now, in regression analysis, there are various definitions which are being given. Some of the popular definitions are given by authors Maurice Hamburg. He says that regression is nothing but a method in which you are trying to estimate or you are trying to predict the value of a particular variable from the knowledge of the value of another variable. In this entire process, we are trying to check whether one variable can be used in order to estimate or predict the value of another variable. For example, we would talk about, demand for a product. Now, in case the price of a product is X and the demand for a product is Y, then we would say that whether Y is dependent on X. For example, currently prices of gold, prices of tomatoes, now both are different products which are there. One is a metal, a luxury one, and other one is an essential commodity. If we are trying to check the demand of gold and the demand of tomatoes, with the prices of gold and with the prices of tomatoes respectively, we are trying to estimate that given a price, what will happen to the demand. So, if the price of tomato is, for example, 100 rupees per kg, if the price goes up to 120, what will happen to the demand? So, what are we doing here? With the variable price, we are trying to identify the demand. If 100 rupees is the price of a tomatoes per kg and if 10 people are buying, if the price goes up to 120, will the demand come down to 8 people? So, what are we trying to understand here? We are estimating the variable demand in relation to the variable price. So, that is what is Maurice Hamburg telling in his definition, where he says that from the values of variables which are known to us, we are trying to understand or predict and estimate the values of variables which are not known to us. So, price of tomatoes is known to us, based on which we are trying to find out the demand for tomatoes. That is how regression analysis works. Another definition is given by another author called Ya-Lung Chol, where he says that regression is nothing but trying to establish nature of relationship between the variables. Basically, here we would say that the relationship is functional, where we are trying to understand how the variables are related there, so that it helps us to predict one variable in the presence of another variable. So the relationship between the variable is also being explored in this particular definition. Now, in these two definitions, I have used the word variable. Now, what is this variable here? Variables are of two types in regression analysis. One is called as an independent variable and one is called as a dependent variable. Now, the variable that is predicting the other variable is called as the independent variable. So, independent variable is one which is helping us to get the value of another variable, that is called as that's why the word independent, that means it is not dependent. So, independent variable is also called as predictor variable or explanatory variable, because it is explaining or it is predicting the value of another variable here. So, here if we go back to our example of price of tomatoes and demand for tomatoes, then we would say that price is independent. Price is helping us to know the demand. So, price is explaining demand or price is helping us to predict demand. So, price will become independent variable here, right? Then comes dependent variable. The variable which is being predicted or the variable which is being estimated is called as the dependent variable. Now, these two variables, because we are doing an analysis, they are presented in the form of a regression equation, wherein these two variables have to be denoted by some letters there, because we are talking about an equation. So, in the equation, the independent variable is denoted by the letter X and the dependent variable is denoted by the letter Y. Now, these dependent and independent variables, basically in regression, we understand regression in terms of simple linear regression or simple linear equations. Now, linear is something which is straight and simple is one where we are talking about only one independent variable which is there. So, dependent and independent variables have got a mathematical relationship with one another. Let us understand what is this mathematical relationship. Now, relationship here is not functional. Relationship is only mathematical. It means that when we are saying dependent and independent, they may not necessarily be causing or having a cause and effect relationship. That means values of y are dependent on values of x, but x variable may or may not be causing the change in y variable. For example, we will talk about sales and advertising expenditure. Now, if a company wants to find out whether if they increase their advertising expenditure, sales also increases. Maybe they have done an analysis for 6 months where they found out that advertising expenditure is increasing, sales is also increasing. So, with the help of advertising expenditure, they are able to predict sales. But for every increase in sales, the same increase may not be associated with increase in advertising expenditure. There can be multiple other reasons related to that. The sales might have increased because price might have come down, competitor exited the market, government changed their policies, customers don't have any other option to buy. So, there can be many other variables which may be impacting. So, the cause of rise in sales need not necessarily be because of rise in advertising expenditure. Sales and advertising expenditure both are related, but not necessarily one causing the other one. So, the cause and effect relationship may not be established as such in a simple linear equation, but there is a relationship which can be expressed mathematically. This has to be the baseline of the entire regression analysis, where we say that the relationship between the variable is only mathematical. It may not be functional. For example, I will give you one more example related to rainfall and yield of a crop. If rain increases, does the yield of crop also increase? So, when we are trying to identify relationship between these two variables, that is rainfall and yield of a crop, if one increases and other also increases, it may not necessarily be because of the independent variable. It may be because of other reasons also. Probably the farmer got better seeds, he has used some other pesticide or fertilizer, because of which that increase might have happened. So mathematically we are able to prove, but the cause and effect may not necessarily be proved. It may be proved or may not be proved. So in regression we need to remember that the dependent and independent variables are related mathematically. There need not be a functional or a cause and effect relationship between these two variables which can be there. So in regression, when we talk about dependent and independent variables, the x and y, we are explaining mathematical relationship. It may not exactly explain cause and effect. That is what this entire discussion also would basically lead you to. Then regression equation, how do we establish the relationship? Regression equation is simple, linear, as I said. Simple because we are using only one predictor or one independent variable, and linear because the relationship is a straight relationship between the two variables. That's how we explain regression equation as y is equal to a plus bx, where a and b will be constants. B basically is used as slope of the regression line or slope of the estimation line. How does it slope? Whether the slope is positive, upward to downward, or downward to upward, or whether it is parallel. There is no relationship which is there. So that's how the B is the slope line, A is the constant, x and y are the dependent and the independent variable. So in regression equation, we will see that regression equation is expressed as y is equal to a plus bx, where y is on the left hand side, what we are trying to find out. So y will be our dependent variable. Y is dependent on, because we are saying y is equal to. So on the left hand side, whatever we have in our equation, that is what we are trying to find out. So in regression, what are we trying to find? We are trying to find the dependent variable. So y is the dependent variable, and x, which is on the right hand side, is your independent variable. So x is the independent variable, and a and b are constants, b basically expressed as the slope line. And for every increase of 1 in x, y also changes by an equal amount. The word which I used earlier was linear. Linear exactly means this, that for every 1% increase in x, y also changes by 1% only. So if x is changing by 1, y also should change by 1. That is what is the meaning of the word linear. If as x increases by 1, y also increases by 1. X decreases by 1, y may decrease by 1. So that way we are trying to explain the relationship which is linear. For every increase in x, y also changes. Changes means it may increase or decrease. If the relationship is positive, it increases, negative, it decreases. That is, inverse relationship is there. So for every increase in x, y also changes by equal amount. We are not saying y also increases. Y may increase, y may decrease. X increases, y may increase or decrease. So dependent variable is y. Y may go up or come down. For example, price of tomatoes, which we took earlier, 100 rupees. Now if 100 rupees is the price, if the price increases 110, will the demand also increase by the same percentage? If it increases, then we say that the relationship is positive. If it decreases, price went up, therefore people are not buying, so demand is decreasing, which means the relationship is, there is a negative slope of the curve or the regression line which is there. So for every increase in x, y is responding by an equal change. That change can be either increase or a decrease. So how do we express the regression equation now? We say y is equal to a plus bx, where y is expressed on the left hand side, which is our dependent variable. X is expressed on the right hand side, which is our independent variable. A and b are the constants. B basically is the slope of the regression line which is being used. Now let us take few more examples here. For instance, what is the repair time which is needed to repair a computer? Now, repair time needed for computer repair may be dependent on how many parts of a computer were being damaged. If more parts were being damaged, means that more time is needed to repair. So, now you see the nature of relationship between these two variables, time needed for repair and number of components which are needed to be repaired. That is one. Similarly, take an example of a vending machine. Take a cool drink vending machine or a coffee vending machine. Now, if the number of cases which are there inside the vending machines are gone empty, so the vending machine is gone empty. Now, I have to refill the vending machine. So, what is the time needed to fill the vending machine and the number of cases which are needed to fill the machine? So, both of these are related, time needed and the number of cases. If the number of cases are more to fill the machine, then I will need more time to put all those cases into the vending machine. So, time needed and the number of cases. Similarly, let us talk about machines or tractors which are used in a farm. Now, what is the maintenance cost of the tractors? It may also depend upon how old is the tractor. If the farmer has been using a tractor since 20 years, it means that he will have to incur more maintenance cost for that particular tractor. If the tractor is new, then the maintenance cost is low. So, the age of the tractor and the maintenance cost again are related to one another. So, they are expressing the relationship here. So, in each one of these examples which I have quoted, the entire statement you can read it as y is a function of x. So, y is the dependent variable which is a function of independent variable x. Y is equal to a plus bx. So, y is dependent on value of x which is there. So, for example, say an operation supervisor is measuring how long it takes for one of the drivers to put 1, 2, 3, 4 cases of soft drink into a soft drink vending machine. In this case, the explanatory variable is the 1, 2, 3, 4, those cases of the soft drink, and then how she is controlling those cases in order to fill that particular vending machine. That expresses, and all this is expressed in the form of a scatter plot or a scatter diagram, where on two axes, on axis x and on axis y, when you imagine a graph or you see a graph on the screen, you would see that there are number of cases and the loading time. So, based on these number of cases and the loading time, you can express the relationship which can be going, and then the slope of the line which can also be plotted onto a graph. Similarly, if you talk about a farm operation student who is interested in doing a research related to what is the maintenance cost and the age of the tractor. Now, if that particular student is taking telephonic survey of, say for example, paddy growers in Telangana, and then he provides questions which are related to age of the tractor and maintenance cost. In maintenance cost, he may be asking about fuel, lubricants, repairs, consumables which are all used by the tractor, and then he is asking about the tractor's age. So, now this researcher wants to link the age of the tractor and all these costs, fuel, lubricant, repair, consumables. He wants to link these two. So, on x axis he can put age of the tractor, and on y axis he can put all these costs together, and from these 52 farmers, when he is collecting the data, he can plot this data onto a scatter diagram, onto a graph, and then he can check where all the points are falling and then express that in the form of a regression line. So, that way it will help him to understand if the age goes up, will the cost also go up? If the age is less, will the cost be less? That relationship between these two variables can be explained with the help of this particular diagram which is being presented. Similarly, now all this in regression analysis, we are trying to understand, basically this is all assumption. You see, when we say price of a commodity and demand, we are only assuming. Tractors, age and cost, we are again assuming. Or for example, talk about number of children in a family and family income. Now, if we want to express relationship between what is the income in the family and will the family's income be sufficient for the number of children. So, we try to say that there is no relationship between family income or number of children, or we say that there is a relationship between family income and number of children in that particular family. So, we can see whether the relationship is positive or whether the relationship is negative, or whether there is no relationship which is there between the plotted coordinates which are presented onto the screen, where we have number of children which are expressed on on x-axis, and family income which is expressed onto the y-axis. So we see the slope of the line where the points are all fitted, which will tell us the relationship or the nature of relationship which is there. If you just see, if the slope of the line or the slope, that is change in y along the line as you go up 1 on x while following the line, that means both the lines are, there is no increase as such, it is remaining constant, then in that particular case it means that there is no relationship, which means that if income increases, number of children also increase. If income increases, there is no change in number of children, children are same, income keeps increasing, but there is no change in children. So here we conclude that there is no relationship. Income increases, but children not necessarily will increase. So there is no relationship. Or we can also say that when income increases, number of children also increases. Maybe families think that, if I have one child, let earning increase and then we will plan our second child. So when the earning increases, they go for the second child. So that way what happens here? Income is increasing and children are also increasing. So therefore, here the relationship is a positive relationship which will be there, slope of the line will be a positive slope. On the other hand, we can also see a negative slope where people say that, what if income falls? Then they say that let us not plan to have children. Then in that particular case, there will be negative relationship which will be there. So that way we can end up saying, but this is a very rare case which may not practically happen as such. So that way, what are we trying to express? We are trying to express what kind of a relationship is there between all these variables x and variable y in all these examples which we have used. And when we draw the regression equation or draw the regression lines, we are expressing x and y as dependent and independent variables. So regression line will be for both. So regression line will be for y on x and x on y. So y on x will be y is equal to a plus bx, where y is the dependent variable, x is the independent variable. Similarly, if you are wanting to find out reverse, the opposite way you want to go, then you can take it as regression line for x on y. First regression was y on x, where we say y is equal to. So y was on the left hand side. Now we will say x is on the left hand side, and then we say x is equal to a plus by. So here it is only the positioning of the variables which is actually changing, where the value of y changes with a variation in the value of x, and in the equation x on y, change in x variable is dependent on change in y variable. That way we can express regression line for both variables, that is regression line for y on x and also regression line for x on y. Both ways we can express the regression lines. Now all this while I was just telling about only one dependent variable and one independent variable. What if the dependent variables, what if a particular dependent variable is getting impacted by several independent variables? For example, think about buying a house. Now when you want to buy a house, that particular decision of buying a house may be dependent on square footage, number of bedrooms, number of bathrooms, age of the house, whether or not the house may have a parking lot, a garage or a swimming pool, or where is the house exactly located. All these will be the factors. So here my decision to buy a house is not dependent only on price. If it was only on price, then it is only one variable, dependent and independent. But here my decision to buy a house, which is the y variable, dependent variable, is dependent on so many factors which are there, so many x variables are there. So in such a situation, we don't run a simple linear regression, but we run something called as a multiple regression, or we compute multiple regression, where your regression equation will not simply be a plus bx, because a plus bx was one where there was only one independent variable x. But now you have multiple independent variable x, x is there, z is there, a is there, b is there, so many are there. So in such a situation, when you have so many variables which are independent, then you express the multiple regression equation in the form of y is equal to a plus b1 x1, that is first variable plus b2 x2, x2 second independent variable, b3 x3 third independent variable, b4 x4 fourth independent variable. Like that you will have multiple independent variables when one variable is dependent on so many things. So my decision to buy a house is dependent on x1, which can be price, x2 which is location, x3 which can be number of bedrooms, x4 it can be square footage, x5 it can be garage or parking lot, x6, x7, like that multiple variables up to infinity you can go. So when you have so many variables, your regression equation also should include all these variables. So therefore y will now be expressed as y is equal to a plus b1 x1 plus b2 x2 plus b3 x3 up to bn xn, how many ever number of variables are there. That way we try to express the relationship between all these variables which are there. This is for multiple variables when you have. So here now we were talking about, initially I started telling you that correlation and regression go together. Now let us see what basic difference is there between the two. Correlation, regression both are statistical tools only, statistical measures only, but in correlation we are only determining relationship or association between the variables. But in regression we are trying to describe independent variable numerically which is related to a dependent variable. So we are trying to identify two variables are different and the value of one variable is dependent on the value of another variable. In correlation we were only saying the existence of relationship, but here in regression we are talking about estimating the value of one variable from the value of another variable which is there. So here in this session today we have spoken about what is meant by regression analysis, where we began explaining the meaning of the word regression, where we said regression is nothing but going back or returning, which was used by Francis Galton in the year 1877, who was an English scientist who was doing research on hereditary related things, and he was trying to understand if there is a relationship between height of a father and height of a son, where he was the first one to use the word regression, where regress means going back or relating back. And the line which he used to describe the tendency to go back is called as a regression line. Modern authors have used the word estimation line instead of regression line. So in regression analysis, what are we trying to do? We are trying to estimate value of one variable from the value of another variable. So value of one variable is known. From the value of that particular variable, you are trying to find out the value of another variable which is there. And this relationship between these two variables need not be functional. That means it need not be explaining cause and effect. It may only be mathematically explained, where we say that y is equal to a plus bx. Y is the variable which is dependent and x is the variable which is independent. A and B are assumed to be the constants, B specifically explaining the slope of the line, where we talk about whether there is no slope, where the line is parallel to x-axis, or the slope is downwards or the slope is upward, explaining positive or negative relationships, and multiple examples of variables which are related in terms of sales and advertising, demand and price, rainfall, yield of a crop, age of a machine and the cost incurred for that particular machine, repairs for the machine and the number of components in the machine. All those things can be related in terms of a regression equation as such. And in this regression equation, we also need to remember that in case there are many variables which are used to express the relationship, then that particular relationship is expressed as multiple regression analysis and not a simple linear equation. Simple linear equation is basically used only for one dependent, one independent variable. But if we have many independent variables, then all those variables will become a part of the regression equation, where it will be expressed as y is equal to is expressed in terms of all those independent variables which are there, x1, x2, x3, x4, all of them along with their respective constants which are expressed in the form of the regression equation. So, this analysis basically is about what is meant by regression, what is meant by variables dependent and independent, what is a regression line, how does it look like, whether it has a slope or doesn't have a slope. If no slope, it is parallel. If there is a slope, whether it is sloping upward to downward, positive or negative, downward to upward. And then we are also trying to understand between the variables what kind of a relationship exists, and also trying to understand whether the regression lines are y on x or x on y. These all things also will be taken up in the form of problem solving in our next session, but for this session we try to understand what is regression, what are variables, what is regression analysis, and how do you fit the variables into a regression equation. This was about what is meant by regression as a part of your topic business statistics regression analysis. Thank you.